Hey everyone, it's Justin again. In the last lesson, we talked about domain and range. Now we'll review how to write these sets of numbers in interval notation. Or if you haven't seen it before, we'll introduce you. By the end of this lesson, you should be able to list sets of numbers, such as domain and range, in interval notation. First, we'll review the rules of interval notation, or introduce you to it if you haven't seen it before. We'll write domain and range in interval notation, and then we'll practice 3 examples. Let's look at a function for which we found the domain and range last time, x squared. So what were the domain and range again? Do you remember? Or can you find them? That's right. The domain was all real numbers, and the range was all real numbers greater than or equal to 0. Now, we should also refresh ourselves on writing in interval notation. Let's go over all the rules for this style of notation. The number on the left is the lowest possible value of the domain or range, and the number on the right is the highest possible value. When there is no lowest possible value, we'll write negative infinity, and we write positive infinity if there's no limit on how high we can go. Now, you may notice that one of the parentheses looks different, the one next to the 0. That's not a typo. It's actually super important. This particular interval describes the range of f of x equals x squared, the function in the graph on the left. If we put a normal set of parentheses here, that would in fact be an incorrect way to write this range. If you see hard brackets around the numbers, that means the numbers themselves are included in the set. Whereas if you see soft parentheses around the numbers themselves are not included in the set. The above set, 3, 12 in hard brackets, represents all numbers between 3 and 12, including 3 and 12. Another way you might see these written is 3 to 12 inclusive versus 3 to 12 exclusive. Inclusive means including the 2 numbers at either end, and exclusive means excluding. Be careful though. If we're excluding 3 and 12, it does not mean that we're starting at 4 and ending at 11. For example, 3.2 and 11.9 would still be included in the interval of 3 to 12 exclusive. Those numbers are both greater than 3 and less than 12, so they are in the interval. You could also see a mix between inclusive and exclusive. For example, the set on the right would be all numbers between 3 and 12, including 3, but not including 12. The difference between brackets and parentheses is generally the difference between a less than symbol and a less than or equal to symbol. On a number line, parentheses would be marked as open dots, and brackets would be marked as solid or closed dots. One other important distinction to know is that soft parentheses are also used for infinity. Whenever you see infinity written in interval notation, you should always have soft parentheses on it. The interval at the top, 3 to 12 inclusive, will stop when it reaches 12, but the interval negative infinity to positive infinity keeps going on forever in both directions. Infinity is not a real number that can be contained in an interval. You should always use soft parentheses for infinity, whether positive or negative, because the interval can never actually reach infinity and stop. Let's find the domains of the log base 10 of x, and we'll write our answer in interval notation. Remember, you can't take the log of a negative number or 0. That's why this graph has a vertical asymptote at 0 and does not appear on the left side of the coordinate plane at all. However, it does stretch infinitely far to the right. That means the domain is from 0 to infinity, not including 0. So we use soft parentheses on the 0 end. And we always use soft parentheses for infinity. So this is our answer in interval notation. One last rule we should talk about for interval notation is the union of 2 intervals. Some functions skip over certain numbers or intervals. For example, think about the function we just worked with, the log base 10 of x, but make it the log of the absolute value of x instead. That graph looks like this. And let's say we're still looking for the domain for this one. This actually solves the negative issue. Negative numbers are now back in the domain because the absolute value makes sure we won't end up with negative numbers inside the log. But the absolute value of 0 is still 0, which is still a problem inside of a log. Take a look at the graph. We still have an asymptote at x equals 0. That means 0 is now the only number that's not in this domain. So, how can we write a domain of all real numbers except 0 in interval notation? The answer is to make two intervals, one on either side of 0. The domain of this function would be written as negative infinity to 0 together with 0 to infinity. We always put soft parentheses on infinities, and we'll put them on 0 as well because 0 is not included in this domain. We connect the intervals with this U sign that represents the union of these two intervals. Neither of these two intervals can cover the whole domain by itself, but when united, they join forces to represent the whole domain. You would use this union symbol anytime you need to list a domain or range that comes in more than one piece. Here's a quick summary of the interval notation rules. The intervals should be written lowest number to highest number. Use hard brackets when the start or end value is included in the interval, and soft parentheses when the start or end value is not included in the interval. Remember, infinity always gets soft parentheses, and the U symbol means union, and it combines intervals. Always use the U if you have more than one interval to include in a domain or range. Let's try some examples. How should all numbers less than or equal to 10 be written in interval notation? To construct an interval, we need a lowest number, a highest number, and then some kind of parentheses. Well, here there's no lowest number less than 10, so we'll be starting with a negative infinity on the left. The highest number less than or equal to 10 is 10. We would need to include 10 since it's less than or equal to. So we would have a hard bracket on the 10 side. And then, as always, infinity always comes with soft parentheses, and this is our answer. Now let's try an example of finding the range of a function and writing it in interval notation. What's the range of the function f of x equals x squared minus 3? Let's take a look at the graph provided. We're asked for the range. The range is all possible y values or outputs of the function. It looks like this function goes up infinitely high on either side, and it reaches as low as negative 3. Think about the equation too. X squared can never be negative, so the lowest x squared could get is 0. If we then subtract 3, the lowest it could get is 0 minus 3, or negative 3. So, then the range would be all real numbers greater than or equal to negative 3. How would we write that in interval notation? Well, we need a lowest number, a highest number, and then some kind of parentheses. Negative 3 is as low as this function can go, so that's on the left side of this interval. On the right of this interval, there is no limit to how high it can go, so that's infinity. Infinity always gets soft parentheses, but on the left, negative 3 is included in the interval, so there would be a hard bracket on that side. And that's our answer. We'll do one more example. What's the domain of the function f of x equals the square root of x plus 1? Notice that the plus 1 is happening inside the square root here. Do you remember that list of domain restrictions? What can we not do with square root functions? The domain of this function cannot include any numbers that would make the inside of the square root negative. If the inside of the root, x plus 1, must be greater than or equal to 0, then we can only work with numbers greater than or equal to negative 1. Then That's the domain. All real numbers greater than or equal to -1. So how would we write that in interval notation? Pause the video now and see if you can write the interval notation correctly. The answer is -1 to infinity, including the -1, since it was greater than or equal to. In this lesson, we learned interval notation, including the proper use of parentheses and how to take the union of two intervals. No, I said union. Yeah, okay, there we go. Keep these rules in mind, since they're going to be useful in the upcoming lessons. See you then!